So this is 8.3 in pre-algebra, section called surface area. And so what this is kind of a combination between area and volume, although we're not finding how much room inside a box we're looking at, or the room inside of like a pop can. But we're looking at a three-dimensional object, and I guess that's where I get the idea of volume. We're looking at the three-dimensional object. Let's say we've got a pop can here. And what we're interested in is how much aluminum it's going to take to make that pop can. Now somebody had to figure that out so that when they make a Pepsi can, they know exactly how much aluminum it's going to cost, so they know how much it's going to cost to make the can, so that they can add that cost to the price of the soda that's in the can. So anyway, it is an important thing to learn, and we're going to start first of all with a rectangular box here. And in order to find the surface area of a rectangular solid is what they call it. In fact, I'm going to just take a picture of that and we'll just look at it. Okay, so there's our picture. So in order to find the surface area, what we're doing is we're finding the area of this rectangle, and we're finding the area of this rectangle, because if we were trying to figure out how much cardboard it was going to make or take to make that box, we'd have to find the area of each of these sides. We're going to find the area of the top, and then after we're done with all that, then we have, in fact, let me see if I can get rid of what I've got up there so far. I've shown three different parts of it: the top, the side, and the front. But there is also, let me make a dotted line, these are hidden lines showing that you can't see what's going on back behind this box. But we have a side of the box back here that we have to find the area of, and the area of this, as well as the area of the bottom. So in any kind of a rectangular solid, we have 6 sides: top, bottom, front, back, left side, and right side. And we're going to find the area of each of those sides, and then we're going to add those areas up, and that'll be how much cardboard or metal or whatever we're making this box out of. That's how much we're going to need in order to build it. And again, we're talking about area, so it's always going to be in square inches, square feet, whatever. So let's say, for instance, that this box has a height of 5. And this is not an example, I'm just making this up, a length of 8, and let's say this width down here is also, let's make it 6. So what we're going to do is we're going to find the area of this side here. And once we find the area of this side, we've also got the area of this back side, so we don't have to do it twice. So the area of this side here is going to be 5 times 8, which is going to be 40. So we know that the area of both those sides is going to be 40. So we're going to put a 40. I have to do this in blue here. We've got 40 plus 40. So we've got those two sides done. Now let's look at the front and back. Let's put this back where it should be. Alright, so the front is 6 and the height is 5, so this is going to be 30, which means the back is also going to be 30. So we're going to add 30 plus 30, so we have 4 of the 6. Now let's look at the top. The top is going to be 6 from this, and it's also going to be 8 from that. So 8 times 6 is 48. So the top is going to be 48, which also means the bottom is going to be 48. So then I'm going to add 48 plus 48. And notice I have 6 numbers here. I'm going to add those all together, and that will give me the surface area. And again, if this is in inches, squared. So add all 6 of these numbers up, and whatever you get, you're going to put right there, and that will be the surface area of that rectangular cylinder, or that rectangular solid. In this next section, surface area of a cylinder, they give us three different formulas because it kind of depends on our particular cylinder on what we're going to use as far as finding surface area. So, this first one here says that if this solid is open at both ends, you're going to use this formula here. 2 times pi times the radius times the height. So this would be, an example of this would be a straw. A straw doesn't have a top and it doesn't have a bottom, so we don't have to find the area of the top or the bottom because it doesn't exist. We're just looking at the area of around it. So we're going to use that formula there. This one here where it's closed at one end. So let's say that we have a can of soup and we've taken the lid off of it. The lid is now no longer on here. So when the lid isn't on there, that's not going to be part of our surface area because it doesn't exist. So what we're going to be interested in is the area of the circle here, the bottom of the can, how much metal it's going to take for that, and then the amount of metal we're going to need for the sides of the can. So because we only have one end, we're going to use the area of one circle, pi r squared, and we're going to add the area of the can itself. So we're going to be using this formula here, the surface area of that. This is actually, this part here that we're looking at, or this here, is called the lateral surface area. It's the up and down. It's the area around that we're going to need of the can. Okay, now let's say that we've got a full can of soup, and it's got a top on it, and it's got a bottom on it. So we're going to take the area of the top and the area of the bottom and double it. So that's why we're going to take the surface area of the circle, pi r squared, and we're going to put a 2 in front of it, meaning we have 2 of those circles. And then we're going to add the lateral surface area, clear from over here, the area of the soup can without a top and the bottom. So here's the top and the bottom, here's the sides. And those are the three formulas that you're going to use in all these. So if you're to look at example number 2, it gives us a drinking straw. So again, we do not have a top or a bottom of a drinking straw, so we're going to use this formula right there in order to do that. And this particular problem says our radius, and it helps me to write down what my variables represent. So that's 0.125. It tells me my length is 6 inches, or length would be another word, another way of expressing height. So my surface area is going to be 2 times pi times my radius times my height, or my length of my straw, which is 6. Multiply all those together and I'm done. So just use one of those three formulas in each of the problems they give you, depending on whether you have a top or bottom or neither, and should be fairly straightforward as far as using those formulas. Another important surface area to remember is the surface area of a sphere. So like of the earth or a ball. Surface area is 4 times pi times the radius squared. So put that in your notes there because you're going to be needing that. So if we have a sphere or a globe or something like that, let's say that the diameter is 12. And we want to find out how much material it took to make that. Well, our surface area is going to be 4 times pi. Oops, we have an r, and here we have a d. Well, if you remember, diameter is always double the radius. So if we take half of the 12, that will give us our radius squared. So our surface area is going to be 4 pi times 36. And keep multiplying and multiplying, and pretty soon you'll have the surface area of that sphere with a diameter of 12. So this is example 3, and what we're doing here is we have a right circular cylinder with a half a sphere on top, and they're telling me that it's closed on the bottom. So I'm going to have to find the area of the bottom. I'm going to have to find the lateral surface area, and then I'm going to have to find the area of surface area of half of that sphere. Half of a sphere is called a hemisphere. So we're going to be looking for 3 different parts here. So what we're going to have to do is find 3 different parts, add them all up, and then we'll have our total surface area. So let's go ahead and look at what we've got here. We've got surface area equals the bottom, which is going to be down here, the area of that. And we're going to add the surface area of the side of the cylinder, like I called the lateral surface area, this part right there. So I'm just going to put LSA for lateral surface area, so I'm going to add that to the bottom. And then I'm going to find the surface area of the hemisphere, the top here. So that's what we're going to do with this. Alright, so let's first of all find the surface area of the bottom. Surface area of the bottom. And that is a circle. So the surface area, or the area of a circle, is going to be pi r squared. So I'm going to write pi r squared as my first formula. So that's the bottom. Got the formula there. My lateral surface area, if you remember from the pictures that I had up here, is going to be one of these formulas, and it's going to be the formula that has a bottom but not a top. And that's what they said here. We have a bottom here but not a top. But if you remember right, over here we already found the bottom. So this side here, since we have the formula for the bottom here, we don't need to worry about it. So we're looking for the side of this thing without a bottom. So we're going to use this formula right here. So notice it looks very similar to this one with one bottom, because when we write this, we're going to get 2 pi r h. So this and this are the same formula. Alright, so now we've just got to find the surface area of the hemisphere. And we said that the surface area of a sphere is 4 pi r squared. But since we're dealing with just half of this guy, we're going to put a 1/2 there. So whatever we get when we multiply all this, we're going to divide it by 2 or take half of it. Alright, so let's put some numbers in here. 3.14. And my r squared of my bottom has got a radius of 5, so 5 squared, plus 2 pi, and again my radius is, well, let's take that pi away and put 3.14 times my radius times my height. And then we're going to add, let's get this out of the way here so that I can continue on with my adding. 1/2, going to make a little bracket here, 4 times 3.14 times 5 squared. Now I just have to put all these numbers together, multiply those, and I get 78.5. Add all, or multiply all of those, and I get 314. Do all of this work, which is a blob, and I've got 157. So when I'm all done and I add all those together, I get 549.5 square inches of material to make this odd looking thing there. Okay, so that's it for section 8.3. The problems are no different than what we just did and we had examples of, so you should be fine with all of that.